Continuing the 5.3 notes today. So I'll just scroll down to page 2. All right. We have only been talking about simple random samples up until now, SRSs. Well, now we can do what's called stratified, where we take a sample and we split it into distinct groups called strata. So I keep using the high school as an example. We could easily split our high school population into 4 strata: freshmen, sophomores, seniors, juniors, seniors. And that way we can get individual data about each of the 4 groups, and we can combine that to get total student body data. So if you want to find out something individually about 2 groups and about those groups combined, you can do one stratified sample, which is really doing multiple SRSs with the same questions. Okay, so we're step 2, taking a separate SRS of each strata and combine these results to make one complete sample. So here we have an example of a university that has 30,000 students. Only 3,000 of those are grad students, and that's 10%. An SRS of 500 students gives every student the same chance to be in that sample. Okay, first we're going to calculate how many, or what chance do you have of being chosen for that sample. So take the total number of students, which is 30,000, because the 3,000 are included in that. And then we're going to do 500 divided by 30,000. So each student has a 1.7% chance of being chosen for the sample. And we multiply that by the number of grad students, so multiply that by 3,000. Only 50 grad students would be chosen. 50 isn't really a large enough number to get a good sense for a group's opinions or results. So we want to do more than 50. So how would we change that? We would break this group into 2 strata. We would do undergrad and graduate students separately. And then you could decide how many from each group. Maybe you wanted to do 500 from each group, 500 undergrads and 500 graduates. Then you can get opinions from each, and if we were to combine these, you would just convert the graduate students down back to their 10% level and make sure the undergrads are at the 90% level. So it's just a multiplication. But if we want individual strata, you wouldn't have to do anything. So take strata, do more than 50 grad students, do 500 of each, or whatever number you want, but something larger than 50. All good samples are probability samples. These are samples that are chosen by chance, which means you somehow randomly picked them. Even if it wasn't random among the whole group, it was just random within the senior class, it was still random. So is a stratified random sample a probability sample? The answer is yes. People were still randomly chosen, even though one group may have been chosen more frequently than another. Okay. Looks like this. The first one here is just a normal SRS, where you're going to randomly choose 5 people, and you're going to use the random digit table that they included. That way we're all be picking the same 5 random people. So remember, we're choosing 2-digit numbers. So we're going to divide the random digit table into groups of 2. And we're going to pick the first numbers. First 5 are between. We're going to use the 100 people listed in the data bank as our population. So we're going to use the first 5 numbers between 00 and 99, because I guess we're going to do 100 people. 00 and 99. So we won't be throwing any of them out. So the numbers over here will be 96, 74, 61, 21, and 49. And then you'll go to your table and you'll find the weights for those numbers. So the weight for person 61 is 112 pounds. So we would write that next to 61, which I thought was the first one, but it's the third one. So 112 pounds goes right there. And then you'll average that out and we'll get our sample mean, our statistic. Let's see, a systematic sample. We didn't really talk about this in the notes. First value must be a random number. Random number, sorry, this number. Okay, so a systematic sample is where you randomly pick the first number and then you go up the same amount from there. Does it tell us how much to go up? Digit number between 0 and 99 inclusive. The random number would be nope, I missed something. Total number of values 100. Sample size 5. 20. So the first value must be a number between 1 and 20. And then we're going to find the first two-digit number that's less than 20. Okay, looks like 18 is our winner. Go on to grow until you find the first two-digit number between 0, 0, and 20. This random number would be 18. Find the nth number. Okay, hold on. I just had to check. So we're actually then going to go up every 20th number. So the first person is going to be number 18, and then we're going to systematically go up 20 because that was 100 divided by 5, which was the sample size. So then the next one will be 38, and then 58, and so on. So the first number is picked randomly, and after that, it's systematically find their weights and average them up. Now in the back we do stratified, which is what we've been talking about today. For the first one, we're going to break them into males and females, because those are marked that way, because obviously those two groups are going to have different weight profiles. So we're going to divide this data into two subgroups based on gender. There are 50 males and 50 females in the bank. Since we want 6 values, we need to choose 3 values from each subgroup. Okay. Use the table of random digits to select which males and females to choose. Start with line 125 and choose the first 3 two-digit numbers between 0, 0 and 49. Just like we did 0, 0 to, or you could do 0, 1 to 50 because you're still in the 2 digits. Question that might come up. Number 0, 0 is not on there. So then you would use person number 100 would be person number 00. So actually then I want to change this. I don't want to do 00 to 49. I want to do 01 to 50. Alright. So these would be all the males in our sample. No, we cannot count only males. So we cannot use the ID number for this. Our first random. Okay. So, problem with this one is the chart is not labeled by males. So, November 23rd, male. So we're going to look for numbers between 0, 1, and 50. So I got 21. So 21 is our first male, but it's not person number 21, it's male number 21. So down here, I need to count until I get to my 21st male. 1, 2, 3, 4, 5, 6, 7, and so on. 8, 9, 10, 11, 12. Keep counting until you get to male number 21, and that weight is what you'll put right there. Okay, wherever you leave off for your males, we're going to do the same thing for females from 0, 1 to 50, and then we'll have to start back at the beginning and count our females in that order. The same kind of thing is going to happen here. We're breaking it up into subgroups based on marital status and comparing those weights. Maybe divorced men are heavier than married men. Let's find out. So we need to choose 2 people for single, 4 people for married, 2 people for divorced, and 2 people for widowed based on these percentages up here, 20, 40, 20, and 20. It has told us how to assign these numbers. And we're still going to start at 125 and then just move on to the next one because we're going to need more lines here. And just like on the last one, if you get number 12 as one of your things, it's not the 12th person in the table. It's the 12th single person in the table. So I need to look at marital status and count until I get to the 12th S. Okay. However, since you know that there are only 20 S's, maybe it'll be faster to count backwards to the 12th S instead of forward. All right, so that's what we're doing today. Bring questions to the meet, please.